In this particular talk, we're going to have a look at image transforms, which is to say how we can scale images, rotate images, translate images, and we can use these different effects by way of building up our scene within our game. So we'll start off by having a look at transformations and the different types of transformation that we are interested in. And there's several ones here. We actually have a couple we can look at. So resizing is one where we may have a source image and we want to draw that source image either in a bigger or smaller format. Rotating is another type of transform we're interested in, that we have an image, but we want to draw it so it is rotated about normally its center point or some other point of reference. Faded, that we want to draw the object so that it is partially faded in or faded out by way of sort of giving an appearance or disappearance effect. And flipped as well, where we swap the sides around, where the left hand side becomes the right hand side or the top becomes the bottom. So we'll look at each of these in turn as to how we can produce a base of code in Android that will do it, but also why would we want to do it. So I'll start off first of all with resizing, and if you have a look at this screenshot, you'll notice, for example, that the tree type structures that we have within it is the same graphic, more or less, but we are drawing it at different sizes to give the appearance of visual depth within the scene. How can we do this? It's a fairly simple principle. We want to draw a part of the source image. Now that could be a section of it for an animation. It could be the whole of the image as well. And we want to say that that is drawn to a destination area on the screen. And the destination area may be bigger or maybe smaller than the source area, and that will correlate then to a scaling of that image. So if you want to have a piece of code for this, well, we've got a few variables that we'll use here. We'll assume we have a bitmap image. Sake of argument, assume it's a 100 by 100 image. We will have a couple of rectangles, one for the source, which is the region of the bitmap that we're copying from, and the other for the destination, which is the region on the screen that we're drawing to. We'll also have a paint and a matrix object, and these we will use to help control how we draw the particular bitmap. Now, given those, the fragment of code that we can see here is one that will enable us to scale. And from line 2 down to line 7 is where we are copying a 50 by 50 pixel region from the center of our source and scaling that up to be a 100 by 100 region as drawn on the screen. So first of all, in line 4, we're setting the source of in the original image to 25 across from the top, 25 down from the top left hand side is the top left point, and the bottom right point is then 75, 75. So that defines a 50 by 50 region in the center of that image. The destination, now the top left is also 25, 25, so this is the point which we're starting from. But now our bottom right point is 125, 125, so this defines a rectangle of size 100 by 100. Given those two rectangles, we can go to our canvas object and call draw bitmap, specifying in the name of the bitmap we want to draw, and also the source and destination rectangles, and the paint, how we want to paint that out. And that will take the contents of the source rectangle and scale it up to whatever size destination window we've specified. From line 9, 10, 11 and 12, it shows how we can accomplish exactly the same thing, but in this case we're using a matrix. So a matrix is simply a way of multiplying the points so that you can manipulate those points in a certain way. And you can create a matrix that will scale them. So it will multiply the points by some scaled value. So at line 10, we're calling one of the methods that's defined within the matrix, and we're saying we want to set a matrix up so that it has an x and a y scaling of 2.0. In other words, it will double the size of the x and the y values, and this corresponds to a doubling of the drawn size. Line 11, we are also setting up a translation that by default the image, the 0, 0 is the top left, but we're saying, okay, when we're drawing it to the screen, we want to move it down 25 by 25. So it gives a translation to that. And then with line 12, we can call our canvas. We can say we want to draw a bitmap. We're drawing the image. We're going to pass in this particular matrix, which will translate the image and then scale it and then paint the thing out. So that's an example of how you use a matrix to bring about scaling too. Why when we want to resize, useful for depth of view effects, for representing things that are further away from the camera. Enables us then to reuse objects and draw them at different sizes, but it's still the same object. And we can use it for effects that zoom in and zoom out. So it's quite a flexible setup. Next one up, we'll have a look at rotation. Again, it's used depending on the game. If we have a sort of a 3D or a 2D environment, we're looking down onto it, we may want to have some objects within that environment that are able to move around. And we could visually illustrate that by changing the rotation of the bitmap. When we're thinking about rotation, we need to be clear about what it is we are rotating around. There's two pieces of information needed for rotation. One is the degree of rotation. How many degrees or radians are we rotating around? Is it 30 degrees, 45 degrees, 70 degrees? And the second one is, what is the point of rotation? What's the center point that we are rotating that shape around? Normally for a lot of these things we will assume that we want to rotate it around the center of the object as opposed to any other point. So we have three variables here. We've got our bitmap, we've got our paint, and we're going to use a matrix here for doing our rotations. This is what we will need to use. And a fragment of code here that rotates 15 degrees, but about two different center points. So line 4 to 7 is the first rotation, and line 10 to 13 is the second. So we look at line 4. I should say above, the reason we have declared matrix outside of our own draw is that matrix is a class, and we don't want to be, because we're calling draw frequently, we don't want to be constantly creating and then discarding objects. So we declare a matrix once and then we reuse it within this particular class simply by way of efficiency. So line 4, we don't know what state matrix is left in. We reset it just to make sure it's back to a safe starting point. We then say we want to rotate by 15 degrees. Now, by default, when you rotate an image, it is rotated about the 0, 0 point, which is the top left corner. So this will rotate 15 degrees around the top left corner. As long as you're holding that top left corner static, not moving it, and then shifting the image by 15 degrees around it. It says clockwise rotation, so there's a convention here that if you have a positive rotation, it is in a clockwise direction. If you have a negative rotation, you're rotating in an anti-clockwise direction. So line 5, we say we want to rotate 15 degrees. For the Android one, the variable that's passed in here, it is in terms of degrees as the angle, as opposed to radians. In MAS, actually, it's more common to pass in a radian value, but for reasons of simplicity, they go for simply degrees. Line 6 says that, okay, once we've rotated then 15 degrees around the top left, we want to draw this on the screen at a different point, and the point is 50 out, 50 to the X and 50 down. So this is simply the location at which we will draw the rotated image. Line 7 is how we do it. We say we want to draw this image, passing in this matrix. You'll see the matrix packages together a couple of things here. It packages together a rotation and a translation. In line 9, we're doing more or less the same thing, but we're doing it about the center of the object. And normally this is what we will want to accomplish when we are rotating our objects. So we reset the object as per normal. I get it back to a normal starting point. We then call the setRotate method, same 15 degrees, but we are rotating around point 50, 50. And assuming that object is of size 100 to 100, then that is indeed the middle point. After that, we simply translate and we draw it out. And if you have a look at the demo that comes along with this, you can see the difference that it makes to what has appeared on the screen. Why might we use this? It's ideal for top-down games where we want to have objects that enable them to move around that environment. Good for graphical effects where we're going to have some notion of spin within it. Next up then is image fading, where we want to draw an image with a particular alpha channel and to have an ability to control that alpha channel. It's just not what is contained within the image, but for us to be able to fade things out more than otherwise they would be faded out. So in this particular case here, we have source alpha, and we're going to multiply that by some specified alpha value. So 50% alpha, 100% alpha, just depending on the degree of fade that we want to have within it. How do we do this? It's actually fairly simple to do. We're going to use the paint object that we've been creating so far. This is the one that will enable us to control just how much fade in, fade out we have. And we can do it here, that we're calling something. We go to our paint method. It has quite a handy set alpha value. So I can say an alpha value of 128, which is 50% alpha. Then anytime I draw a bitmap out, it will take into account the alpha value of that image, but it's going to multiply it by the alpha value that I've set. So it will reduce it, in this case, by an extra 50%. After I've done that, because I'm reusing my paint object, I need to make sure I remember to set my alpha value back to the default of 255. So it's simply based on the image's alpha value. Why might you want to use this? It's ideal for any appearance we want things to fade in or to fade out. Next up, and finally in this, is looking at flipping images, where we either flip along the x-axis or the y-axis, to invert along x or to invert along y. You can see the example over on the right hand side, that if we flip along the x-axis, then what was the right of the object becomes the left of the object, but the top and the bottom are still retained. If we flip along the y-axis, then it's the other way around, that the top of the object becomes the bottom of the object, but the left and the right, they both remain the same. Why would we use this? It's actually incredibly useful within animation. Within animation, you see down at the bottom of the screen, you may have a number of frames of animation. Now, the character potentially could walk to the left, could walk to the right. You don't want to have two sets of animations, one pointing to the left, one pointing to the right. So the normal way of doing this is that you simply have, for example, a right-facing animation, and if you want to draw the character walking to the left, then you flip those images around and it'll appear as if the character is walking to the left. How do we do this? Again, we've got our image, we've got our source and destination rectangles, we've got a paint as well. And you can see here a little fragment of code that will do it. So lines 2 to 7, they draw it the normal way that we've seen before. We set up a source, we set up a destination. So there where we're copying the center 50 by 50 value from our source image, and we're drawing it to a point 400 across 50 down as the top left, to another point 50-50 under that for the bottom right corner, and simply drawing it out. So lines 4, 5, 6 and 7 just draw it in the normal way. Compare that then to line 10, 11, 12 and 13. They draw it flipped along the x-axis. And you'll see for the destination, it's still the same destination. We're not changing that. It's still the same way of drawing it. But what we do change is the source component. And if you were to say, okay, that point 75, 25, that's your top left, and at point 25, 75 is your bottom right, then that effectively has flipped the coordinates around within the source rectangle. And that, when we draw it, will then flip it around and give the appearance that the object has been flipped along the x-axis. Now, the real power of image transformations is when we get to combine them, that we can take these individual effects and combine several of them together to get more impressive effects. So we want to have a look at how we do this. We will need to use matrices to do most of these transforms, and the real power of a matrix is the ease with which you can combine several different transformations together. So I can have a rotation and a scaling and a translation, and package them all up within a single matrix. So it is actually quite a powerful way of doing things. However, and this is important, if you think about multiplication, 4 times 7 is the same as 7 times 4. That isn't the case for matrix multiplication. That if you have two matrices, A and B, and you multiply those together, A and B is not necessarily the same as B times A. Let's give you an example. Here we have ordinary two-dimensional coordinate system, and we want to do two transformations. We want to take our point 2, 2 that's highlighted and translate it by 2 along the x, 2 along the y. And we then want to rotate that point 90 degrees clockwise. So those are two transformations that we want to do. So the first one is we translate 2 along the x, 2 along the y. It brings us from the point 2, 2 to the point 4, 4. If we want to rotate clockwise then, so we're basically viewing that point as being a point in a circle. We rotating here about the origin, that is our default point of rotation. So we can go to the origin and rotate 90 degrees around the origin, and we'll end up then at the point 4, minus 4. Fair enough. If we think then about, okay, let's take exactly the same two-dimensional space, the same starting point 2, 2, but to do these transformations in the inverse order. So we're going to rotate 90 degrees clockwise, and then we're going to translate 2, 2. If we do that, okay, so again it's a point in a circle, translating around the origin 90 degrees brings us to the point 2, minus 2, and then translating out 2, 2 brings us to the point 4, 0. So you can see for transformations, we need to make sure about the order in which we do it, and we are consistent in that particular order. Thankfully, there is a rule of thumb that we can use that will help keep us consistent. So we'll have a look at that now. So if we want to safely combine our transformations, then you can do so using what's known as the Isrot sequence of combinations. You start with the identity matrix. So the identity matrix is simply a matrix that doesn't change anything. You multiply anything by the identity matrix, you end up with the thing you started with. So it doesn't change it. Here, this is an indication that if we have a matrix, we should always make sure that that matrix is reset, that it is a clear, clean, new matrix, or is one that we've called the reset method on. So it starts off from a clean beginning. The next thing we should do is that if we want to do several things, we should always scale second. So if we want to make this image, what we're drawing, bigger or smaller, then after we've reset it, we should scale as appropriate along the x and the y direction. The next thing we should do after that is to rotate. So here we're assuming rotation about the center of the object. So if we do want to rotate, do any scaling first of all, then we do any rotation around the object's center, so we can have a rotation about the center. That's good. Finally, or not finally, but after that is orbit. So if we want to have the object rotated not about its center but about some other point, sometimes you want to do it, sometimes you won't, you would do that after you've rotated around the center, after you have scaled it. And finally, the very last thing we want to do is to translate. So if we say, okay, we want to do all of these transformations, and then to say that the object is drawn at a certain on-screen location, the translation is what we should do at the very, very end. Now, you don't need to do all of those steps together. So if I wanted to make the image, let's say it was a spaceship, I wanted to make it bigger, I wanted to have it rotated to the direction of travel that it was moving along, and I wanted to draw it at a certain position on the screen. I would do the reset it, scale it, rotate it, and then translate it. And as long as I follow those sequence of activities, what I'm imagining in my head by way of the standard way we would scale the image, rotate about its center, and then draw it at a position in the world, it'll work out perfectly fine. So do make sure you adhere to that particular sequence when you want to draw things. If we take these different effects, we can actually do very sophisticated things with them simply by combining them together at different sizes, fade it into different extents, rotate it in different ways. drawn at different locations on the screen. It's a very, very powerful set of abilities and will enable us actually to create particularly impressive scenes. And we have one such example here. This actually, I like this image, is of an explosion effect. And it looks to be a fairly impressive explosion that you see. But there's also a set of 6 images showing up in the top left-hand corner. This explosion that you see is comprised of those 6 images and nothing else. So using 6 basic images, we can combine them together in a fancy way that will produce really quite impressive graphical effects. And if you look very closely at the particular image, you can see that it is repeated, that this image that's drawn here is a composite of lots of other smaller images drawn at different color intensities, at different sizes, faded in different ways. So you can do really quite sophisticated things with it. And one of the things we'll probably do in the lecture, you can have a think about here, is that how would you reverse engineer this explosion? If I give you the 6 images and I say to you, okay, I want you to reproduce that explosion, how would you do it? So have a look at the images there, do decompose it against the different ones that are available, and then think about, well, how you would go about building up that particular explosion. So by way of key takeaways, we've got a couple of them. Image rotation, scaling, fading, translation, they offer you a very, very capable way of controlling how images get to be drawn. It is a very powerful toolkit. Do take the time to think about how the types of images that you will have in your game, how you maybe can combine them using these transformations, and how you can best exploit those by way of improving the visual impact that's inherent within your particular game.